Thank you, Jeroen. Let me share my screen. And then, I'm Guy Hagemans. I'm a cloud integration consultant for Appythings, and I'm really excited to share some of the details on the PostNL case. So as an introduction to the business case for PostNL, the challenge for PostNL was to phase out an old bespoke IT solution that was responsible for information surrounding parcels, and secondly, to phase out all the legacy applications that, for example, are using costly SFTP. Finally, also to provide a future-proof integrations platform in order to be more flexible in how we can deliver to PostNL's B2B and also to the B2C customers. So self-service here is very important because of the number of customers that are using PostNL's integrations. But also to increase the adoption of the streaming platform internally within the organization itself. So to tackle this, we turned to Actual Cloud, which is a powerful platform that offers robust streaming capabilities for handling high volume, but also business critical use cases. We used KSML to perform the many event processing that needed to take place to transform the parcel status changes into outgoing notifications. And our approach included also setting up configuration topics that support business logic. All of this is supported by a series of microservices and that are low code and easy to maintain. I think the journey that PostNL took and how we got here is interesting and good as a starting point to provide to you all. So PostNL started more than a decade ago with their APIs and API management. It was and is a successful project, and the customers of PostNL, the big ones, but also the many small web shops were very, very happily using the APIs. The success, however, also has a downside because high API traffic also means higher cost. And as mentioned before, one important example is the tracking of parcels. So there was an API available for this. This was a GET API, and especially the larger customers of PostNL, which have tens of thousands of parcels in transit, were using this API to get the status like every minute or so for every parcel. And this is inefficient because the status of a parcel sometimes does not change for an hour or even longer. But once the status is changed, you do want to give a timely update to your consumer. So it's much more efficient to push these changes instead of doing a GET request, which we're here referring as pulling the status. So a few years ago, we set up a proof of concept using AWS serverless components and custom code to push these parcel status changes to the bigger customers of PostNL. This worked really well. However, to expand this capability in the organization and to mature it further, the decision was made to leverage mature technology such as Actual on Kafka. I would like to shortly stop by this slide and explain why we chose the solutions that we currently have for PostNL. So this slide is part of the Appythings integration architecture framework. In the integration world, we have different ways of sending data across. We acknowledge the dialogue, event, and file-based integrations. What is important is that there's no good or bad technology, but you have to find the right technology for the right use case. Also important is that you have to size these technologies in the right way in order to be cost effective. And for PostNL, there are thousands of small web shops that want to know where their parcels are in the chain. So for these small web shops, a dialogue-based integration is an optimal solution because it is easy to set up. It requires little to no setup from their side because it's just a simple HTTP GET request. However, the larger customers of PostNL, for example, bol.com, which is like the Amazon of the Netherlands, their volume of parcels and thus also the events is so large that an event-based integration is optimal. So to provide a bit of context before we go into more detail, one of the things we're doing at the moment with the event platform is to transform what we call observations to relevant information. The main input for this is PostNL's brain, being EDS on the left. In EDS, it receives the observations from, for example, delivery van, delivery people, and from warehouses where the packages the parcels are delivered to and shipped from. These observations on their own do not hold much value, but based on rules that are, for example, set by e-commerce, for example, by defining what event updates are allowed to be sent out to PostNL's customers, and by getting the preferences that are set online by consumers, we filter and branch the events and determine the right channel to send the information to. So businesses which are large customers of PostNL might want to receive these events in bulk via a file transfer, a bucket, or maybe in the future even a webhook. But certain consumers might want to have, most of the time want to have their updates on their mobile phone instead of an email or vice versa. So by processing these events in the right way, with the right logic, we create value and we process this data into relevant information. So along the way, during this journey and given this context, a few challenges, of course, emerged. The first challenge we saw was governance. There are multiple parties that are sending events and configurations to our platform. In the future, we expect many more systems to do this and also to consume the data that's being produced. Data governance is key here in making sure that it is clear what data you're working with and what you can expect. But yeah, all these topics will be in more detail later in the presentation. The realization of streaming apps could also be a challenge because you might not have Java developers available, and Java is typically the language you are writing streaming apps in. Security is the third and the last topic. When dealing with customer data, which is often the case at PostNL because we're dealing with addresses, for example, the data is best secured using MTLS. But how do you manage those certificates? How do you manage access to the topics to which the data is streamed? Yeah. So to start with governance. So in this scenario where you have a streaming platform where different departments can produce and consume data to and on, one key aspect of governance is who owns what data on the platform. Because after running the project for a couple of years, you might have hundreds of streams, and there's also many consumers and producers on these topics. And it is a lot of responsibility to keep all of this data running well, because there's just so much data flowing through your platform. So one rule that we found is working really well is whoever produces the data, so in other words, the party or team that is sending the data to the topic, to the platform, they are also the owner and thus responsible for that data. This means that when you have several other teams consuming the data to this topic, there might be questions on what exactly some of the data means. So why was there a hiccup in the data being produced? Why was there a change in the data from a certain time? And of course, as an integration team member, you're happy to help with all of these questions, but it really helps in making sure that the party that produces the data is aware that they have this responsibility, that they are the owner. You'll see it later in the demo, but with Actual, it's very easy to assign a team as the owner of a topic. It's easy to manage this team. And in all of the projects that I've seen, this team is also the owner of the topic and thus the data. Next is the schema lifecycle. So we really recommend using schemas for all of your events, but it's important on how exactly you use schemas and how you review them, because using a schema for your event is a bit like having a database schema, where in the database schema it's also defined in what table you have what fields and with what types. It takes a bit of effort to create these schemas, but on the other hand, with most programming languages, using the schema, you can generate code which based on the schema, which helps in getting back some of the time that you invested. Schemas actually helped a lot for PostNL because when, for example, using an Avro schema, when producing or consuming messages, a message that does not adhere to the schema gets automatically rejected, meaning the code that you're using to consume or produce a message to a topic will throw an error. For a developer, this can be a bit annoying, but yeah, it really helps in making sure that the data adheres to the contract, the schema, and you're not dealing with garbage data, which can create problems further down the chain. So a linked important topic to this is schema reviews, which also touches governance. What we recommend doing is setting up a repository with all the schemas that are currently that you currently have in production. And when the data owner wants to publish a change to the schema, they make the change in a branch, and then when they push the change, a CI/CD pipeline automatically validates the schema for validity and compatibility. There is free tooling available for this from Stoplight. So yeah, finally, when having a central repository with all of your schemas, it's great for other teams who want to have examples, for example, and makes it easy to review schemas. So talking about events and schemas and their design, I'd like to discuss some best practices that are related, which are the following. So it's a good idea to keep an eye out for YOLO events. This means that when any business starts with an event, what happens sometimes is they keep adding attributes, maybe have different styles for the event, and how it should look as they go along with the requirements as they come. So this is not a good approach, because the message could become inconsistent, difficult to read, hard to process. So it's really important to try to find a good balance for an event or actually between an event that has too much information and one event that is too sparse. Because an event that has too much information, we also call it a God event. It contains too much detail about, for example, an order. So for example, it contains the information on the order, how it is fulfilled, what support tickets are open for that order, and much more. An event that is too sparse can also create issues when it is sent to the parties that are consuming this event, because those parties then might want to know more about the event and will start calling, for example, this order API and check on what the details are. So something we were working with at PostNL is what PostNL calls the P360, or the partial 360 degrees event. This model is really nice because it creates consistency and clarity around the organization on how parcel information should be communicated. It basically defines the meta model of a shipment. It also means that the model contains a lot of information. So one thing we did for a stream processing application that helped really in reducing the cost through, for example, reducing processing power and disk storage after receiving the event. We stripped down, so after receiving the event, we stripped down the information that is required for the stream processing application. And this is a simple steps, but it also makes all the steps that process the message further down the chain much lighter. And that brings us to the next topic, which is streaming apps. Before we started the project at PostNL had no experience with event streaming, with an event streaming application on Kafka. So during a workshop together with Actual, PostNL, and Appythings, Actual showed us the alerting solution of the Rabobank in English. And yeah, together with architects from PostNL, we created a high-level design. In design, it was clear what the input and the output would be for every process and business function. And then these would be translated to input and output topics. But the logic in between the topics, that's handled by an event processor. And for PostNL, we handled this mostly by using KSML. For PostNL, there are many event processing steps to be taken for the shipping and other events. And these are often small steps, such as filtering data, changing the structure of an event, branching the event into multiple steps. And to quickly develop these streaming apps, we use KSML, while actually none of the developers in our team are either experienced at all with Java or very experienced. So in the example I have here, I've attached an example on how to rekey or like change the value of a key of an event. So on the top, we can see that we've defined what streams we're using for input and output. And then the function we will run. So it takes the customer number from shipment parties customer number, and then it sets it as the key of the event. And then at the bottom in the pipelines section, you can see the where the data is coming from, what it is doing in between. So it's going to that function that we were just looking at, and then where the data goes to. So yeah, we've seen that using KSML using KSML we can quickly develop these processors, if you will. It's easy also to look back at these processors and check exactly what every processor, what every step is doing. Next is observability. So yeah, given the context that we just looked at before, when business units start to decouple their applications using events, it's really easy to lose track of where what event went, where bottlenecks appeared. Having observability on these topics, therefore, is really important. And in actual, there's a feature called Topic Browser, and we're using this feature a lot. It's also in the demo, but in short, teams really love to see if their event is received in actual to a topic, on what environment, in what form, how many events were received. And we don't have to configure or deploy anything for this. Just by sending an event to a topic, you instantly get this business value, because yeah, we do also get questions from the business side about what happened to this barcode, where is it in the process, did you receive it at all, for example. And with this, it's really easy to check. All right, so for security, I would like to mention a few things. The first one is certificates. Through the self-service portal, stream owners can upload their MTLS certificates themselves. And this is nice because then as an integration team or as a DevOps team, you don't need to have the certificates of the business unit. They can upload them themselves, which is much more secure. Then authorization. So here you see a screen of a user and the roles that they have and that they can have. So when I have the role topic author, I can create a topic. So that's based on a role-based authorization. And then next to the role-based access control, and actually you also have attribute-based access control. So an example is when a user creates a topic, they are automatically the owner of the topic, and they can fully manage it together with actually the group that they are in. Lastly, the regulating topic access. So as a user, you can request access to a topic. So here we can see that there is an application called KSML example processor, and with the exclamation mark, it's trying to be a consumer, by the way. The exclamation mark means that the access was requested, but it's not yet granted. And at the bottom, you can see as a topic owner, you can see the access request, and you can approve or deny it. Okay, so I've mentioned a lot of things about Actual and how we use it, and I think it's time to see it in action.